For f of x equals 1 and 5/10 x and g of x equals negative x plus 1 and 5/10, complete the table of values for each function, and then write polynomials to represent their sum f plus g of x and their product f times g of x. Compare their x-intercepts, y-intercepts, and slopes where appropriate. Graph the coordinate pairs on the same grid to verify these attributes. Okay, let's start by filling out the table. So plugging in our x values, we first have negative 4. Plugging that in for x in f of x, we get 1 and 5/10 times negative 4, which gives us negative 6. Plugging in negative 4 times, plugging in negative 3 times 1 and 5/10. So again, just plugging it into f of x, we get negative 4 and 5/10. And so on. We'll go ahead and fill out the rest of the column. Doing the same for g of x, if we plug in negative 4 in for x, then we get negative 4, so that's positive 4, plus 1 and 5/10, so that gives us 5 and 5/10. And then plugging in negative 3, that's negative 3, so that's a positive 3, plus 1 and 5/10, so we get 4 and 5/10, and so on. So now for our sum, f of x plus g of x, then we can just go ahead and add together just through the row the first two columns. So negative 6 plus 5 and 5/10 gives us negative 5/10. Negative 4 and 5/10 plus 4 and 5/10 gives us 0, and so on. We can go ahead and add together each row. Similarly, for f of x times g of x, then we can just multiply the first two columns. So negative 6 times 5 and 5/10 gives us negative 33. Negative 4 and 5/10 times 4 and 5/10 gives us negative 20 and 25/100, and so on. So now that we have those values, let's go ahead and do the next step and write the polynomials to represent the sum and the product functions. And so first of all, for f of x plus g of x, well, we know f plus g of x is just equal to f of x plus g of x. And so substituting in our functions f of x and g of x, then we would just get 1 and 5/10 x plus negative x plus 1 and 5/10. Then simplifying like terms, then 1 and 5/10 x plus negative x, well, that's just 1 and 5/10 minus 1, because that's like a negative 1 in front there. So that gives us 5/10 x, and then plus 1 and 5/10. And so that is our function for f plus g of x. So now we'll do the same thing for the product. So f times g of x will be equal to f of x times g of x, and then we'll go ahead and substitute in both the functions. And so now that we've substituted in the functions, then we can go ahead and distribute. So 1 and 5/10 x times negative x gives us 1 and 5/10 x squared, and 1 and 5/10 x times 1 and 5/10 gives us 2 and 25/100 x. Okay, so now let's compare the x-intercepts, y-intercepts, and slopes. And so let's use a table to organize our different functions on that. So for f of x here, then we have, first for the x-intercept, let's just look in the table. So that would be when y is 0. Well, here when y is 0, then we see that x is 0. So then our x-intercept is 0, 0. And since the x value is also 0, then the y-intercept would be 0, 0. And then the slope, as we see in the function, is 1 and 5/10, the coefficient of the x value. And then for our g of x function, then similarly, we can't see the x-intercept here from the table. We'll have to solve for that because there's no place in this column of g of x where the value equals 0. But we do have a y-intercept when x is 0. Then we see in our g of x column that the g of x would be 1 and 5/10. So for our y-intercept, we'll have 0, 1 and 5/10. And then for our slope in our function, we see that it's a negative in front of the x. So it's a negative 1 for our slope. And then for f plus g of x, then we see, looking at our column, that when f of x plus g of x is 0, then x is equal to negative 3. So we have negative 3, 0. And then our y-intercept would be when x is 0. So that would be when f plus g of x is 1 and 5/10. And then our slope here would be 5/10, the coefficient of the x value. And then for our last one, f times g of x, then we see here it's a quadratic. So let's just start by saying it's not going to have a constant slope. So that column will be not applicable there. And then for our x-intercept, then we know that that factored, just because of how we multiplied it, we know that that factored to our f of x and g of x equations. So using that, we can get our x-intercept. So for 1 and 5/10 x to be equal 0, then x would have to be 0. So then one of our intercepts would be 0, 0, and the other one, well, that's negative x plus 1 and 5/10. So for that to equal 0, x would have to be equal to 1 and 5/10. So we would then have 1 and 5/10, 0. And then for our y-intercept, then we see here in our table that when x is 0, then f of x times g of x is 0. So then our y-intercept will be 0, 0. And so now let's find our x-intercept for g of x. And so I'm just going to plug in 0 for g of x in the g of x function. And so solving this, then we can subtract 1 and 5/10 from each side. So we get negative 1 and 5/10 is equal to negative x. And so then simplifying that, then we can multiply each side by negative 1. And so multiplying by negative 1, that gives us the positive x, which is what we're looking for. And then negative 1 times negative 1 and 5/10 will just be 1 and 5/10. And so our intercept will be 1 and 5/10, 0. Now let's go ahead and graph these functions with our x-intercepts, y-intercepts, and slopes. Okay, so here we have our 4 graphs. And just note here as we're comparing that, the x-intercept of our f of x and g of x functions, those are the exact same as our f of x times g of x function, as it should be there, since those are basically the factors that make up the f of x times g of x. Also notice here that the intersection of f of x and the sum function, that the x value there is 1 and 5/10, and notice that 1 and 5/10 is also the x-intercept of g of x. And so that is a property that holds true here for the sum functions and one of the addend functions. And so then looking at the y-intercepts, then notice here that for the sum function that the y-intercept is just the sum of the two y-intercepts of the two functions. So 0 plus 0 is 0, and 0 plus 1 and 5/10 is 1 and 5/10. And the product, y-intercept, is also just the product of the two intercepts. So 0 times 0 is 0, and 0 times 1 and 5/10 is 0. And so that is also another property there. And notice that the slopes, that f of x, 1 and 5/10, plus negative 1 gives us 5/10. And so adding together the two slopes does give us the slope of the new line of the sum function. And so now that we've gone ahead and compared, and we've graphed it, and we filled out our tables, let's go ahead and summarize. The completed table, graph, and chart show the polynomial representations of the functions, the x-intercepts, y-intercepts, and slopes where appropriate.